Hi, today let's have a look on this gyro. This one is a gyro unit MK8 made by Ferranti. So you can see this connector. So this kind of connector is very old. I think that this unit was designed in the 50s. I didn't find anything about this instrument. I don't know if it is a vertical gyro or an azimut gyro. On that side there is a shaft which is protected by this stuff here. This shaft can rotate about 90 degrees. This shaft is maybe the roll, but I'm not sure. First, let's open this thing to see what is inside. One screw is very difficult to unscrew. There is a prisoner nut which rotates. You can see this nut here. Okay, on that side we can see two potentiometers and one capacitor. Okay, so let's see the other side. Okay, so the problem is that I need to remove this connector. Okay, so I think I will cut the wires. There is also a ground connection here. Okay, look at that. This is the vertical gyro actually. Okay, so we have the roll and the pitch. Okay, we can see this tilt switch. Okay, we can see here on the right a torque motor. So this provides the torque on the inner gimbal, the torque like that. But because of the precession, if you apply a torque on that axis, there will be a rotation of the outer gimbal like that. So obviously there is a regulation of the position of this shaft here. And effectively we can see, I didn't see here, but there is another tilt switch. This tilt switch is connected to this torque motor in order to regulate the horizontality of this gimbal. The gyro rotor is on that axis here. This tilt switch permits to regulate the position of this gimbal. So we should have a torque motor which permits to generate the torque on that axis here in order to change the position on that axis. But I didn't see this torque motor. It is maybe inside here. Okay, I can see the coils effectively. It is maybe difficult to see with the camera, but we can see several coils here. In conclusion, we have a stabilization of the verticality of the gyro. So therefore, the output corresponds to this shaft. This is actually the roll of the device. So probably a synchro transmitter was connected here, or maybe it is connected to something else, I don't know. I don't know exactly the purpose of this gyro, but it is a roll gyro actually. The output is only this shaft here. So you can see that these two potentiometers are connected externally. Okay, so let's measure some resistances. This is a short circuit between the yellow and the white wire. Here there is a resistance of 110 ohms, 108, 109. So this is interesting. Between each pair of wires there is a resistance of 110 ohms approximately. This should correspond to the AC motor. So we should apply here a three-phase 115 volts AC voltage. So we can see that these two wires, purple and brown, are connected to this capacitor. The resistance is 520 ohms. It is maybe used for the precession coil. This is the reverse engineering of this gyro. We can see the rotor in the middle. This is a three-phase AC motor. For the test, I have used a single-phase voltage, 115 volts here, which is connected across two terminals of this motor. And for the third phase, I use a classic LC network. So we can see here. So I have used a capacitor box and an inductance box. For this motor, the optimum values are 5 microfarads and 0.7 Henry for the inductor. You don't need a specific power supply to use a three-phase AC motor. You can use a capacitor and an inductor. We can see also two tilt switches here. The tilt switches are connected to two torque motors. One is here and second one here. There is a capacitor in parallel to this torque motor in order to have a phase shift. One common point of the torque motors here are connected to the power supply, so this connection should be done externally. And the common point of the tilt switches, this line here, is connected to one point of the AC motor. So I have used another point here for the common point of the torque motors. It is very simple, and this thing works. Okay, so let's go. Okay, you can see the effect of the tilt switches. That's all for this gyro. Thank you for watching and see you next time. Bye bye.